Hello mathematicians, here we are. We are going to be working on Chapter 9, Lesson 5, Polygons on the Coordinate Plane. So your book needs to be open to page 706. I'm going to get set up here and we are going to get started right away. So taking a look at 706, we are first going to start with finding the perimeter. Okay, the perimeter, we're going to go ahead and read what it says here. It says you can use the coordinates to find its dimensions by finding the distance between 2 points. To find the distance between 2 points with the same x-coordinate, we are going to subtract their y-coordinates. Then, to find the distance between 2 points with the same y-coordinates, we're going to subtract their x-coordinates. So what does that mean? For example, let's say I had a rectangle here, okay? And we had these these ordered pairs on a coordinate plane. Let's say this was 1, 3, and this was 1, 5. Oops, it's not letting me write 5. I don't know what's going on. 1, 5, there we go. Okay, and then maybe it's going to act up on me today. Doesn't like me today. I'm not sure what's happening. There we go. Maybe. And then let's say over here, this one is 3, 3, and then this one is 3, 5. Okay, so now that we know that, basically what we're going to do is between the points that have the same x-coordinates. So I'm going to actually just write these down. 1, 3, and I'm actually not going to put them in parentheses. I'm going to put 1, 3, and then I'm going to put 1, 5 because they have the same x-coordinate. And then I'm going to label 3, 3, and 3, 5. Okay, so now let's take a look at the ones that have the same x-coordinate. Okay, remember this is our x, this is our y. So notice these two have the same x-coordinate, which means I'm going to subtract the distance of my y-coordinate. So 5 minus 3 is 2. And notice that I would also do the exact same thing with these two because they have the same x-coordinate. So I would take 5 minus 3, which is 2. Okay, that would be 1. And then to find the distance with the same y-coordinates, so now I'm going to look at the y-coordinates. Notice these 3 and 3 are the same. And 3 minus 1 is 2. Now this is just kind of weird that I picked the same distance, but that's okay. And then 5 and 5 are the same, so those would be taking the x-coordinates. 3 minus 1 is 2. So then I would know that the perimeter is 2 plus 2 plus 2 plus 2. So 2, 4, 6, 8. I know that the perimeter would be 8 units. That would be the outside. Okay, so what does that look like if we're looking at it down here? In this picture, for example, here is a rectangle that is actually labeled with 5 units, 3 units, 5 units, 3 units. So basically all we're going to do to find the perimeter is the outside. It's like finding the perimeter of the fence, okay, of a fence that's outside. It would be finding the perimeter of a schoolyard all the way around the outside, the boundaries, okay? So all I'm going to do is I would add 5 plus 3 plus 5 plus 3, which would give me 16 units. Okay, I would just add those up. So now take a look at this. So here it says rectangle A, B, C, and D have the vertices of 2, 1, and I'm going to write them down. 2, 1, 2, 5, 4, 5, and 4, 1. So the first thing I'm going to do is I'm going to look at the ones that have the same x-coordinate. So I see that 2 and 2 have the same x, which means I'm going to subtract my y. So I'm going to do 5 minus 1. In my head, 5 minus 1 is 4. Okay, so I know that I'm going to add 4 plus, and then I notice that these two have the same x-coordinate, which means I'm going to subtract over here. So I'm going to take 5 minus 1, which is 4. Okay, now I'm going to go look at my y-coordinates. Remember x, y. Okay, I'm going to look at my y-coordinates and see which ones are the same. I see that 5 and 5 are the same, which means I'm going to subtract my 4 and 2. 4 minus 2 is 2. And then I notice I have this coordinate of the y that are the same, 1 and 1, which means I'm going to take 4 minus 2, which is 2. And when I add 4 plus 2, I get 8. 8 plus 2 is 10. 10 plus 2 is 12. That would be 12 units. Okay? All right, so now we're going to actually do this down here for practice. All right, so use the coordinates to find the length of each side, then find the perimeter, which means we're going to add up the total. So let's write these down. Here's our x and our y. Okay, so we have 3, 6, 3, 8, and I would write them down just like this, 7, 8, and 7, 6. So let's start with the ones that have the same x coordinates. This is the same x coordinate, which means I find the difference, means I'm going to subtract 8 minus 6, which is 2, so I'm going to have 2 plus. I notice that these as well have the same x coordinate, so I'm going to take 8 minus 6, which is 2. Now I'm going to look at my y coordinates that are the same. I see this 8 and 8 are the same, which means I'm going to find the difference of 7 and 3, which is 4. And then I see the 6 and the 6 are the same, which means I'm going to look at 7 and 3, which is 4. I'm going to add those up, which is going to give me 4 plus 4 is 8, 8 plus 2 is 10, 10 plus 2 is 12. That gives me 12 units for the perimeter. Okay, let's take a look at this next one. Okay, B. So we're going to have 1 and 4. We're going to have 1 and 9. We're going to have 8 and 9, and then we're going to have 8 and 4. So looking at these, let me adjust this just a little bit. Looking at these, we're going to go ahead and take a look at the x ones that are the same, the x coordinates. So I'm going to find the difference of the y. So 9 minus 4 is 5. I have 8 and 8, so 9 minus 4 is 5. Now I'm going to look at the y coordinates and subtract the x. So 4 and 4 are the same, which means I'm going to take 8 minus 1, which is 7. I see 9 and 9, and that's 7. So I know 5 plus 5 is 7. Or I'm sorry, 5 plus 5 is 10. And then I know 10 plus 14 is 24, which gives me 24 units for the perimeter for that. Okay? All right. Let's take a look at this next page. Okay, so it says, each grid square on the zoo has a length of 200 feet in the total distance. When the x coordinates are the same, subtract the y coordinates. When the y coordinates are the same, subtract the x coordinates. So taking a look from here to here, that is 10, okay? Then you see from here to here, okay, those are the same, so 10 and 10, which means we're going to take 7 and 7. And then from here to here, we see 7 and 10 and 7 and 7, which means we're going to subtract our our y coordinates, which is 3. From here to here, I see that my y coordinates are the same, so I'm going to subtract my x, which is 4. From here to here, I have 11 and 7 and 11 and 3, so the difference of 7 and 3. Here to here, I see that my y coordinates are the same, which means I'm going to take 11 and 7, which is 4. From here to here, I see it's 3. And then from here to here is 7. So when you add all those up, you'll see that you get 42. That's not going to be the units because it says has a length of 200 feet. Okay, each grid has 200 feet. So you would have to take that and multiply that by 200 to give you 8,400. Okay, so take a look at this next one. This next one says the coordinates of the vertices of a garden are 0, 1, 0, 4, 8, 4, and 8, 1. Okay? It says if each unit represents 12 inches, find the perimeter of the garden. So first, let's find the perimeter, and then we're going to multiply that by 12. So we're going to take a look at the the x coordinates, find the difference. I've got 3 of my y. 8 and 8, difference of 4 and 1 is 3. 1 and 1, difference of 8 and 0 is 8. And 4 and 4, the difference of 8 and 0 is 8. When I add those together, I get 22. Now I need to multiply 22 times 12, and when I take 22 times 12, I get 264 inches. Okay, so now let's talk about the area. So when we find the area, you're going to see that we have different, different shapes, okay? And what we need to do, or different, not shape, yeah, they're going to be different figures, and we need to kind of cut it down to figure out how we're going to solve this. So we have to remember, like, area of a trapezoid, area of a rectangle. You're going to see this shape, and I'm going to see that I can make a rectangle, and then here I can make a rhombus. Okay? There are going to be different ways that you can cut your figures into different shapes so that you can use a formula. So, and let's see, find the area and the square unit of the figure to the right. So here's what I would do. I'm going to go ahead and cut this, and I'm going to notice that here I have a triangle, and here I have a, well, I guess this is just a rhombus. So that means that we're going to take area equals base times height, okay, because it's just a rhombus. So 1, 2, 3, there's my base. And remember, my height has to make that 90-degree angle, so there it is, 1, 2. So I'm going to take my area equals base, 3 times 2, which is 6, which gives me 6 units squared. Now, they're not going to be that easy. Some of them are going to have to break up, and we'll practice some of those on some of the other pages. Okay, let's take a look at this example up here. So here's a figure, and they made a triangle. So now what we need to do is we need to use our area. Area equals 1/2, or 0.5, times my base, okay, 1, 2, 3, and my height, which makes that 90-degree angle, 1, 2, 3. So I have 3 times 3. So area equals 0.5, 3 times 3 is 9. Okay, and then my area equals, well, half of 9 is 4.5 units squared, or square units. Okay, let's take a look at this example right here. So it says, graph the figure, classify it, then find the area. So here we go. A, 3, 3, so over 3, up 3. We're going to mark that. And then I have 3, 6, over 3, up 6. And then I have over 5, up 6. And then I have over 8 up 3. And it looks like I have made a trapezoid. So we're going to label it as a trapezoid. And then we have to remember that a trapezoid, for the area, equals 1/2 height. Oops, 1/2 height. And then it is our base 1 plus our base 2. So let's take a look at base 1. 1, 2, 3. There's 3. 1, that is not on the line. 1, 2, 3, 4, 5. There is that. And then our height, 1, 2, 3. So let's fill in what we know. Area equals half our height, which is 3. And then we have our base 1 and base 2. So we have 5 plus 2. I just did the bigger numbers first, doesn't matter. So 5 plus 2 is 7. So now we have area equals 1/2, or 0.5, times 3 plus 7. And so then when I do area equals, and I put it into my calculator, 1/2, or 0.5, times 3 times 7, I get 10.5, and that's going to be units squared. Okay, we are going to, in the second video, we're going to stop there. If you feel like you need more practice, then you're going to join for the next page, or the next video. If you feel like you've got this, it's kind of a lot, but if you feel like you have gotten this, then you're good and you don't need extra practice problems. Otherwise, jump into the next video. Again, it is up to you what you feel comfortable with. If you want to watch the next video, go for it. If you feel comfortable, then stop. We're going to probably do the next 3 on the next video, which is going to be pretty short.